What is up, guys? Nat here. Today I will teach you three things. First is basics on resistors. Second is common application of resistors. And third is tips about the resistors that I wish I'd learned when I was a noob in prototyping. So, resistors are passive components that control current measured in ohms, and their electrical symbols are as follows. Usually in prototyping, we use the through-hole components of resistors. These are the ones that have bendable legs that you could insert through the holes of PCBs or breadboards. So, to know the value of the resistor, we use Colorbands. It could be a 3-band, 4-band, or 5-band, and just remember that the spacing of the last band is always different. And I suggest not to memorize these bands but be familiar, because as you progress in electronic prototyping, you'll find common resistors and have memorized their colors. But if you have a test for tomorrow, I suggest that you keep calm and memorize the bands. Okay, let's have a test and see if you remember the bands by heart. The answers will be on the end of this video, so stay until the end and comment down your score below. So the last basic idea of resistor is the series parallel connection. This is how I learned it, and I hope you understand it with me. So series connection. Resistor in series is when you connect two or more resistors to each other. And parallel is when you connect two or more resistors with each other. Again, these are not textbook definition, but this is what worked for me. Now, for an example, you need a 900 ohms resistor. You could series 100 ohms resistor to each other, or could parallel to 1.8 kilo ohms with each other, and you'll get a 900 ohms resistor. Moving on, the 5 most common uses of resistors are voltage division, biasing, current limitation, bleeding off charge, and pull-up and pull-down resistor. So first, voltage division. Voltage division is used for converting a voltage from higher to lower, which has the formula. And this formula can be solved in Ohm's law, which will be derived in the website. And an example of voltage division is using an Arduino to read the voltage of a 12-volt battery to know if it needs charging. And since the Arduino can only read up to 5 volts, we can't hook up the 12-volt battery directly. So we convert the 12-volt battery to a 5-volt voltage. So if the battery is fully charged, it will be 5 volts in the Arduino, and if the battery is low battery, it will be in the Arduino. Another thing is, these voltage dividers are not power regulators. You cannot use them for powering a device like converting a 12-volt supply to 5-volt supply through voltage division. Hooking up a circuit next to that second resistor changes its overall resistor value, since it will now be a parallel resistor to the second resistor, thus changing their voltage. This is why we prefer voltage regulators, which will be covered in a different video. Okay, number 2 is bias. If you ever used transistors before or seen a circuit of it, you'll see a combination of resistors and capacitors in their circuit. Resistors provide the bias or levels of voltage to control the transistors. We need to bias transistors correctly to use the transistor in off state, active state, or saturated state, which we'll tackle in a separate video for prototyping. In current limiting, number 3, most common example is in LEDs. Too much current in an LED will break it, and too little current will make it useless. And we use this application in our first electronic project, which is the UV LED project. It is always preferred to solve the resistor in series first before connecting the LED. Bleeding off charge. AC to DC power supplies use a large capacitor in their circuit, which means larger capacity for electrical energy, and these capacitors act as a filter in the circuit to convert the pulsating DC of the rectifier to a I'm going too far? Oh, okay. Okay. So after using these power supplies, the capacitors have a leftover charge stored inside them. And to remove their leftover charge, we have two ways. First is by leaving the capacitor to deplete its own charge through time, or by using a resistor to become a load and let the current through the resistor. That's why it's called a bleed off. Capacitors bleed off their charge through the resistor. And lastly is the pull up and pull down resistor. These are used in logic systems. It is known to fix the voltage problem so that you can change from signal to ground easily. For example, looking at this XOR gate, both probes are in 5 volts. So the result is 0 volts. But when the probe is floating, it is still 0 volts. And note that this is neither 5 volts nor ground. And now placing it on ground volt, the result becomes 5 volts. So pull up or pull down resistors needed so that in a push of a button, the voltage will change without having a floating stage. So first tip, easiest way to read the resistor is not by Colorbands, but by using an ohm meter or by using your DMM. You just put it between the probes and then measure. Second tip, download Electrodoc in your phone. It is by far one of the best apps to use while doing your electronic project. It has many applications like seeing the value of the resistor just by the color code or find the resistor near the value you need by using the lookup resistor. There's also a voltage divider calculator, resistor ratio, resistor series or parallel, and many more. It's free in Android, but it's 250 pesos in Philippines. Third tip, buy lots of resistors for your project. A resistor is a cheap component and having spares will spare you the time of going to your electronic shop again. I really hate it when I'm trying to do a project and have to go to the electronics shop to buy parts. Another thing is segregate your resistor. My resistors are just a big disorder. I wish I arranged my resistors in order, but I'm very lazy to do it. When doing parallel connection, remember that the resulting parallel connection is lower than the lowest resistance used. Same goes with series. The resulting series connection should be higher than the highest resistor used. Another tip is on wattage. Before you buy the resistors you need, simulate your circuit in your software and find out how much current will pass through the resistor. This will save you the time and frustration in prototyping. Another tip on wattage is the tip that I love and very late to know in my student life. It's the N by N Resistor Matrix. For example, you need a 5 watt 100 ohm resistor, and the only wattage of resistors you have is 1 watt. You need to use an N by N matrix, and it's a lot of soldering, but it's a good way for more power. The formula is N times wattage of the resistor. So to get a 5 watt resistor, we need a 3 by 3 1 watt 100 ohm resistor. Each resistor will only take this amount of power, which results to 5 watts. Okay, last step, potentiometers. They give out a variable resistor value by turning their knobs. And you need to understand how it works first. There's a resistive track where both ends of the resistors are connected and a wiper on the middle. So to get the overall resistance, we just connect the 2 probes of our DMM to the ends of the potentiometer. And to use it as a variable resistor, we connect one end of the resistor to one probe and the other probe to the middle. So as you move the wiper farther away from the end, the resistance increases. And moving closer, resistance decreases. Personally, I don't normally use potentiometers because when I simulate a circuit, I already know the resistor values needed for my circuit. These potentiometers are mostly paired in a voltage divider to change their voltage. Thank you guys if you stayed up to the end of this video. You are awesome. and what are the things you do with resistors, go ahead and comment down below. Also, it will help this video and my channel to grow if you go ahead and leave a like. Comment down if you need any help, and you can reach out to me on my Instagram or via email. Subscribe if I deserve it, and stay tuned for more prototyping tutorials. Bye. I almost forgot. I will be making a prototyping 101 cheat sheet. So for this video, we have resistors, and then I'll make a cheat sheet on it. I just want to help you with your electronic life, because as a student before, I never had anything, and I just wanted to give part of my knowledge on prototyping. So that's it. Bye.